Okay, this is section 4.3, calculus, page 220. It's how derivatives shape a graph. If you look at derivatives, remember that a derivative is a slope at a point, at one point along a curve, right? And on the bottom of page 220, they show us a graph that has the slopes, and you'll see the red lines on that. Do you see that? And those are tangent lines to a curve. And you can see from A to B, the slopes they're increasing. Is that true? And from B to C, they're decreasing, right? And notice that from B to C, one of the red lines is on top of the graph, and one of the red lines is on the bottom, right? That's kind of interesting. We'll get to all that. But what we want to look at is what happens with the slopes on a graph, so that we can either help us graph it or help us understand more about the graph. Okay? So on page 221, we get the increasing decreasing test, and it says, what is f prime of x? What does that mean, f prime of x? What's that notation? Just to remind yourselves. It's the derivative. So that's slope, isn't it? That is slope. If the slope is greater than 0 on an interval, then f is increasing. Does that make sense? If your slope is positive, then your f values are increasing. All right? So what happens if our slope is not positive? It's negative. It's decreasing. F is decreasing. Do you guys get that? If our slope is increasing, it comes up. All right? And then if it's decreasing, it goes down, doesn't it? The graph goes down. Does that make sense to you? Okay? So what we're going to look at is what we call a first derivative test. And I'm going to jump around in the book a little bit. But we're going to talk about it, the first derivative test. This is on page 222. And it is a test to see what's happening on sides of points. All right? It says, suppose that C is a critical point of a continuous function. So C is a critical point. You remember talking about this in the last section, what a critical point is, right? You remember how to get a critical point. And then do what with it? That's exactly right, okay? So we find the derivative of f of x and set it equal to 0. So we're talking about this C is a critical point. All right, now it says A, right? If the derivative, which is f prime, changes from positive to negative at C, that means at that point, then we have a local what?
Maximum.
Max. So what happens is, our slopes are going up, they're positive, and then now they're going down. Look what happens. That point right there, that critical point, that is a max. Now, we can only say that it's a relative max, can't we? Remember, relative and local mean the same thing? We can only say that is a relative. We don't know that it's absolute, but we can say that. Do you understand that? All right, now what happens if the f prime changes from negative to positive at C? So it's coming down, right? Mm-hmm. And then all of a sudden it's going back up, the slopes. At that critical point it changes.
Relative.
All right, and I'm going to use relative minimum instead of local. I prefer relative, honestly.
Same thing though, right?
It is the same exact thing. Yep. Now, if f prime does not change, okay? For example, f prime is positive on both sides or negative, then it has no local max or min. Now we're gonna define this a little better in a minute, okay? But I just want you to understand. Now they show this on, right in the middle, right after this. You see that? The first one is a local, max, it's clear to the left. The next one is a local min, and then the next two are examples of where there's no max or min. Do you see them? They kinda look like this, okay? Since I showed this, they kinda look like this. Okay, where at this point, that critical point right here, that it keeps going up and then it goes up again. Now, the weird part is we're gonna talk about this in a minute. This is what we call concave down. Okay, concave down. So concave, the cave is pointing downward. This is called concave what? Up. Do you understand the difference between the two? Concave down looks like this. If I took my hand and like this, well, I can do that. And concave up looks like this. I always say concave up holds water, concave down drops water. Right? You had water in your hand? Okay, so you understand the two differences. Okay, so what we're gonna look about is we're going to take a point and we're gonna start working on this in a minute. But I'm gonna talk about the second derivative first. And this is the first time I've ever talked about the second derivative before working with the first derivative, but we're gonna see what happens. On page 223, it says, what does f double prime say about f? What does f double prime? This is the second derivative, right? Do you understand that? This is the second derivative. And it says, figure 5, see figure 5, which is right below it, shows the graphs of two increasing functions on the interval a to b. Both graphs join point A and B, but they look a lot different. You'll see that in one, it looks like this from A to B, and one looks like this from A to B. What's this one called? What you just learned?
Concave up.
Concave up is when all the tangents are on the bottom. Do you remember when I first showed you that picture and I said we'll have tangents on both sides? We'll talk about that in a minute. Well, that's what it means. If you have the tangents on the bottom side of the curve, this is concave up. If you have it on the top, it is concave down. Do you understand that? And it says that on the bottom of page 223, if the graph of f lies above all tangents on an interval of I, then it is called concave up. If the graph of f lies below all tangents on I, then it is concave down. Does that make sense to you? Okay, take a look at the next page 224. They show a lot. From A to B, it's called what?
Down.
Concave down. From B to C, it is concave up. From C to D, it is
Down.
down. And then D to that next point, E, concave up. You can see that they're going back and forth, right? All right, see the next paragraph under it? It says, let's see how the second derivative helps determine the intervals of concavity, right? Looking at figure 6a, which is back on the other page, from left to right, the slope of the tangents increases, right? The next line is kind of important. It says this. This means that the derivative of f prime, guys, which was f double prime. If you take the derivative of f prime, you get f double prime. Do you understand that?
Mm-hmm.
All right, is an increasing function, and therefore its derivative, double derivative, is positive. So if your f prime is increasing, then your second derivative is positive. Then it goes on to say, likewise, the slope of a line decreases from left to right, so the f prime decreases, therefore its double derivative is negative. All right? So, there's a concavity test right underneath that, correct? That says, if, I'm going to try to put this on here if you can see it. If f double prime of x is greater than 0, that means it's positive, right? Then it is concave up. Now think about that. Your hand is like this, right? It holds water. and that's positive. That's how I remember. Holds H2O. Put some little science in there. It holds water, right? If your double derivative of x is less than 0, it's concave down. That's negative. You can't hold water. Okay? So it looks like this. Now, oddly enough, if we have something that is concave up, the first one, it is what on the bottom of it? It's what? If I have a critical point on the bottom of this, is it a relative max or min? It's a relative min. If I turn it around, this is a relative max. Now, it doesn't have to be that way, but it can be. Do we have any questions so far? All right, we're good? All right. Okay, so let's take a look at the second derivative test. Now, remember the first derivative test? Now I kept that because I'm going to go back to the second derivative test, and we're going to talk about the first and the second derivative test as we go through an example. The second derivative test says if the derivative of c, now remember c is a critical point, equals 0. All right? And the double derivative of c is greater than 0. That means the second derivative, okay, then we have a local minimum at c. Now, we just talked about that, didn't we? With my hand, remember? If we have a critical point, okay, and it holds water, we have a minimum point, right? Then the other is true. If the derivative of c is equal to 0, and the double derivative of c is less than 0, so it's like this, we have a local max at c. We just talked about that, correct? That's the second derivative test. All right. Okay, so we have about 10 minutes. I'm going to give you an example. Okay? You ready? Example 6. On the bottom of page 225 says, discuss the curve y equals x to the fourth minus 4x cubed with respect to concavity, points of inflection, local max, and minimum. Now, we have not talked about an inflection point, so I'm going to jump back up. I skipped it. I'm sorry. I missed it. On page 225, a point P on a curve y equals fx is called an inflection point if f is continuous there and the curve changes from concave upward to concave downward, or from concave downward to concave upward. So look at this. If I do this, right, concave downward to concave up, this is called a point of inflection. Now, your first derivative test can also tell you if there's a point of inflection too. Do you know how? If the left side of it is positive and the right side of it is positive, it means that you haven't changed the slopes. So it's a point of inflection. Now, let's do this. All right, here's example 1. Let's say that f of x is x to the fourth minus 4x cubed. All right? So we first need to find the critical points. How do we do that? We find the derivative. And that is 4x cubed minus 12x. And I'm going to find the second derivative. Oops, squared. Thank you. I'm going to find the second derivative right away too, okay? Because we're going to do that also, right? And that is what? 12x minus 24x. Okay. Now, would you do me a favor and let's factor these so we can set them equal to 0, right? So this, I'm going to pull out a 4x squared, and that leaves me an x minus what? 3. So I have two critical points. They are at what? What's that?
-3 is 1.
3 is 1.
The 3, yeah.
3 is 1. What's the other one? What about this?
2.
0. If you put 0 in there, you get 0, right? Let's go ahead and factor this one too. I'm going to take out a 12x and I get x minus what? 2? Is that the case? All right. So let's start with the critical points. All right? Are we good? Okay, what I'm going to do is I'm going to put the critical points on a number line. We're gonna have 0 and 3, all right? Okay, let's check the area over here, and let's check the area here, and let's check the area here to see if these are maximum or minimum points. Now let me show you. We're gonna do slopes, right? So tell me a point over here. By the way, this area is a negative infinity to 0. Do you agree?
Yeah.
And I'm gonna use parentheses because we're not gonna touch it because we don't know what's gonna happen. So, and this is 0 to 3. Notice I use parentheses again. I know no brackets. Are you okay with that?
Yeah.
Okay. All right, let's check the area over here. I'm gonna put in -1, and I'm gonna put a -1 into my my first test. That is a first derivative test. So I'm checking the slopes. If the slope is positive, then all the slopes over there are positive. So I'm gonna put a -1. When I put a -1 in here, I squared it, it's positive, right?
Mhm.
Are you following this? So this is positive, right? And what's a -1 minus 3? It's negative, right?
What's the
-1 minus 3,
What's plus negative?
Negative 4.
right? So it's -4. So what's a negative times a positive?
Negative.
So this area is negative, right? Okay, now let's go to here. I'm gonna pick 1, is that all right? 1 is between 0 and 3. Put 1 in. That's 4, and that's a -2, right? All right? It's negative.
2.
Did it show this? What's that?
Putting 2 in for the last one?
Yes.
4.
I'm gonna put in what?
Or 4 actually.
I'm gonna put in 4, and this is what?
64. Positive. 4. It's positive.
It's positive. So from here to here, right, the slopes are negative, and then we're going positive. So they're going down and then up. What's this point?
Point of inflection.
No, it's going down and then goes up.
Oh,
Relative
relative minimum.
That's the relative min. So the point 3, put 3 back into the original. What do I get? 3 to the 4th power is 81 minus,
108.
is that 108?
Yeah.
So what's 81 minus 108? Use a calculator.
Negative 27.
-27. So we said 3 and -27 was a relative minimum. Is that correct? Now what's happening here? The slopes were going down and then continue to go down, correct?
Uh-huh.
That's a problem. We'll come back to it in a minute. Let's use the second derivative test. Okay, let's set that equal to 0.
Should we already set that one?
Yeah, we did. We just didn't write it out. But I'm going to do it down here. Is that okay? So what do I get for x? 0 and 2. All right. Are we good? Does everybody see how I got 0 and 2? All right. Do you remember the second derivative test? It said if the second derivative was greater than 0, right? It was a local minimum, and if it was less than 0, it was a local max, and then it was a point of inflection if, right? If we add that, if it didn't, if it wasn't those two. All right. So we do the same thing here. All right. Let's put 0 and 2. All right. Okay, now we're using a second derivative test, correct? So we're talking about concavity. Do you understand that? Concavity. These are not critical points. Well, actually 0 is, because it matches from our first derivative test. But 2 is not. But something happens there. Something major happens there, okay? So let's look at points here on this side. A -1. If you put a -1 in here, what happens? What do I get? This is negative and this is negative, so I get positive, right? Do you agree?
Yeah.
Okay. So all the points here are, that means that it is, it is concave. What? It's concave up. Alright? Now let's go in between here. What do we got? 1 is positive and negative, so it is, so this is, now notice, this is different. This is, we're finding concavity, right? And let's do 3 here. What do we get? 3, we get a positive, so this is concave up. Does everybody understand that? Alright. So, look at this. We have a change from here to here, right? What did they tell us when the concavity switches from one to the other? It was like this. What's this called? Alright, so 0 is a critical point, but it is a point of inflection, isn't it? What about 2? It is also a point of inflection. They're both points of inflection. Okay, now you're saying, well, how does that help us? Well, we're going to end today because we're about out of time. But take a look at, I'm going to slide this over. And I don't know if you can see this very well. But take a look. Here's your graph of what we just said. What happened at 0, 0? And I didn't find the y values, but if you put 0 in, you get 0 back, right? So that's a point of inflection. Do you see that? That where we have concave up going to concave down, that's a point of inflection. Does that make sense to you?
So are they gonna ask you to make the graph on these?
It's possible. That's where we're headed.
Oh, so
okay.
like, what did this question have asked?
This question just said, tell us about, discuss the curve of this. So we just discuss it. We wouldn't actually graph it. We just discuss it. But I think it's important that I show you what's happening graphically. So take a look at 2, and I didn't find the y value, but it's negative 16. Same thing. We're going concave downward and then concave upward. So it's a point of inflection. The only true critical point, they're all critical points, but is this one, isn't it? And it's a relative max. But that's what that graph looks like. And look how the test helped us to see what was going on at those different points. Would we have known that they changed concavity at this point if we hadn't done a second derivative test? No. We'd looked at it in our graph and would have never known that that was the point where it changed. Okay? All right. So what I want you to do is, the bell's about to ring. I want you to do these, and you're going to struggle a little bit, but we'll go over it again tomorrow. Okay? But page 327, numbers 1 through 3, 28 through 32, and, oh, I forgot 7 through 11. 7 through 11. Okay? Now, please do not do 8, C, and D. 8, C, and D, we'll talk about those if we get time in class. But skip 8, C, and D, okay? All right, now you're going to struggle on this, so don't panic. We'll go over it again tomorrow, all right? All right. Wow, time that